This is David Levine. I'm here with Dr. Jamie Reaser. So I'm going to read Dr. Reaser's bio. Dr. Reaser has worked in more than 70 countries as a biologist, communication psychologist, and international environmental policy negotiator. She holds a PhD in biology from Stanford University and a BS in field biology from the College of William and Mary. Much of her career is focused on delivering science into the policy context. This has included science advisory roles across the U.S. executive branch and multiple components of the executive office of the president, as well as providing direction to the United Nations agencies, foreign governments, and private sector leadership. She's the author of more than 100 publications of the science policy interface across a wide range of environmental issues, amphibian devices, coral bleaching, climate change, invasive species, biosecurity, infectious disease, among others. She's particularly well known for using her multidisciplinary expertise and multi-sector professional network to develop solutions to seemingly intractable environmental issues. She's also regarded as a public figure in literary circles. She's the award-winning author of more than a dozen books in poetry and prose genre. So Dr. Reaser, thank you for joining me in August, and I appreciate that. And unfortunately, we had to cancel a few weeks ago, so I appreciate you coming back. Why don't you give an overview of your career, and then you have a presentation to make.
So thank you, David. I appreciate the opportunity to be here and to reschedule, given the unexpected challenges I had on our last scheduled date. I think you did a pretty good job of giving the overall background professionally. I think the one update I would give that's relevant at the moment, I recently joined the Smithsonian Institution, or actually rejoined the Smithsonian Institution, where I'm directing a project to assess the risk of zoonotic disease for all wildlife that is imported into the United States legally and illegally. That will not be the focus of my presentation this evening, but certainly something that I would be interested in talking about for those writers that are pursuing wildlife trade related issues. The presentation this evening is actually based on work that I did over the last couple of years with colleagues globally to develop a new framework for looking at how we stop pandemics at their source in ecological systems. So if it's all right with you, I'll just go straight into that overview, and hopefully it will generate a good discussion for us.
Okay, go ahead.
Visible?
Not really. It's just now it is.
Okay. So the advent of COVID-19 has taught us quite a bit about pathogen biology, as I think you're all aware by now. It's also demonstrated where we have failed to learn lessons from prior outbreaks of infectious disease. We should, for example, have learned from the bubonic plague, among other large-scale disease outbreaks, that community-scale epidemics and global-scale pandemics can be prevented by addressing the environmental circumstances that facilitate these disease outbreaks. Things like sanitation and the associated control of rodent populations, as in the case of bubonic plague. Looking at the state of ecosystems around the world should open our eyes to the substantial risks, the setup that currently exists for more large-scale disease outbreaks. Where there are unhealthy ecosystems, there are risks to human health emerging and re-emerging diseases that have the potential to again reach pandemic proportions. Malaria is an example of well-known correlation between unhealthy landscapes and the risks of human disease. Studies have shown that the biting rates and the larval abundance of malaria transmitting mosquitoes strongly correlates with the level of deforestation in the tropics. For every 1% of deforestation, the incident rate of malaria has increased by 11%. Disease prevention obviously must address the root causes of disease emergence, the conditions that allow for mosquito population explosion in this case, which we know is things like standing water. So attention needs to be given to land use more explicitly as the primary driver of zoonotic disease outbreaks, ideally before the first human case is detected, taking a precautionary approach.
Dr. Reaser,
Protecting nature.
Could you define, I guess I have a question, can you define zoonotic disease outbreaks?
So zoonotic disease outbreaks, zoonoses, as it's sometimes called for short, are pathogens, disease-causing microbes that can be transmitted from animals to humans. That's wildlife, could be domestic animals in some cases, and then ultimately to humans. Clear?
Yes.
Okay. So the strong message to start with and take away from this presentation is that protecting nature protects human health. So as I mentioned in the opening comments, I have been working with a team of colleagues around the world to develop a conceptual framework that takes us from this general correlative situation, such as I described with malaria, into a more fundamental mechanistic science, one that would enable us to identify points of intervention for preventing the epidemic or pandemic scale disease outbreaks. So we've called this particular model land use induced spillover, LUIS for short. The idea here is that pandemics start with wildlife that has been stressed, technically referred to as an infected reservoir host, but all you need to know is it's stressed wildlife. Wildlife that's been stressed because there has been some sort of change in land use. In a landscape context that may be terrestrial, but may also be aquatic and marine. So when I use the term land use, I'm actually meaning any type of ecosystem. And we've identified 4 stages in what we call the land use induced spillover model. The first one is infect. The second one is shedding of the infection of the pathogen, then shedding of the pathogen, then the pathogen spilling over from one species to another, and then ultimately spread within human populations. And I'm going to describe each one of these stages briefly. The key takeaway from this slide is that the driver in this series of events is land use change. And that land use change may be as explicit as clear cutting a large area, but it could also be for some species more subtle. Perhaps it's light pollution or sound pollution. That's the stressor for a particular wildlife species in a particular context. So starting with infection, it's important to remember that we have microbial organisms naturally circulating in the environment. And not all of them are pathogentic, not all of them cause disease. Disease is set up as a result of changes in the relationship between the host organism, wildlife in the case of our model, and the microbial organisms that it's in relationship with. So there's a long history of association between zoonotic pathogens and what is referred to as reservoir animal hosts. And those stressors, as I mentioned, that can cause a microbial organism to become pathogenic may be biological or they may be abiotic, broadly environmental, ultimately resulting in the increase in the proportion of the wild animals that are infected, as well as the rates and scales of infection. So this is a scaling issue to a large degree in terms of infection. So once the animals are infected, in order to move to the next stage in the process, they have to release those pathogens from themselves, either back into the environment or directly to another organism, or in some cases through a mediator, through a vector. And we call this process shedding. It's essentially a releasing or a transmission of the pathogens from the initial wildlife hosts. So the mode of release, the way in which the shedding happens, determines the ultimate route of transmission towards humans, towards the human animal. So that shedding might occur through bite from the animal itself, a bat biting a human, for example. It might occur through a vector bite, a tick or a mosquito, transmitting it to an intermediate host. That term means another animal that exists in the chain between the wild animal that we're starting with and humans. So in some cases, livestock plays an intermediate host role. It may also be that those pathogens are shed in feces or urine. For example, there have been cases where monkeys have defecated on picnic tables in parks in Africa, and tourists have picked up diseases from enjoying their picnics at those picnic tables. And it's also possible that these pathogens are released through animal slaughter, and that's one of the reasons why bushmeat, for example, has become a concern in the transmission of diseases to humans. So that's part two. Then we move from shedding into what we've shortened here as spill, but the broader term is spillover. And spillover generally means the transmission from one species to another species. And of course, in this equation, we're ultimately concerned about spillover to humans. So it requires that humans have direct or indirect contact with the pathogen via the modes that I just discussed. It also requires that the new host, technically referred to as the recipient host, has to receive a sufficient dose of that pathogen. Just like I mentioned, the initial wild animal in the equation has to have a sufficient number or scaling of pathogens for it to become truly infected and be able to start the chain of events. And importantly, that pathogen needs to be compatible, biologically compatible with the new host. We're constantly being exposed to microbes in our daily lives, but they don't reach pathogenic levels in our day-to-day experiences because we're often not compatible with them. They may be pathogens that would be compatible with birds, but not necessarily compatible with humans, for example. And then ultimately, to get your epidemic and pandemic scale events, you have to have transmission potential of that pathogen from person to person. And that's not the case for all pathogens. So spread requires that the pathogen can be efficiently transmitted from person to person. And that usually is transmission that is rapid by way of the mechanism of transmission, and relatively casual in terms of the mode of transmission. So things that are airborne, for example, are more likely to move on to epidemic or pandemic scales. So we developed a model to describe this model as simply as possible. And that is what we call the domino effect. If you consider dominoes, I hope everybody at least has had some opportunity to play dominoes in their life and have some sense of what that involves. But if you imagine standing a series of dominoes up on end, that could represent a healthy ecosystem. And when we're talking about healthy ecosystems, we're generally meaning that the structure and function of the ecosystem is intact. And one of the features of having an intact structure and function is that you have resilience. If there are perturbations in the environment, you can respond to them without long-term adverse consequences. So in our model, this would be an ecological system where wildlife stress is within normal limits. There are going to be stresses that come and go that might be weather related, for example, but animals can respond to those stresses in a way that maintains their basic needs. So we would say these dominoes are secure, pathogen dynamics are balanced with wildlife dynamics. In an unhealthy ecosystem, you can imagine tipping that first domino so that the whole series of dominoes starts to fall. And what tips that first domino is land use change in our model. So your structure and function has been disrupted, wildlife is adversely stressed beyond its resilience limits, and the pathogens start to proceed through this infect, shed, spill, spread cascade. We've developed two other terms in this model that help us ultimately understand the dynamics, but also respond to the dynamics constructively. The first term we developed is called landscape immunity. And landscape immunity governs the infection and shedding part of the equation. So what that means is if we have a healthy ecosystem, we have strong landscape immunity. So there's a conveyance of immunity in the broadest sense and resilience to the wildlife. So for maintaining your dominoes upright, for the infection and shedding, you want to maintain landscape immunity to protect and restore ecological systems. As we move later into the system to the spillover and spread, the governance of those two components is what we refer to as dynamics of proximity. So it really comes down to exposure and contact rates between people and the animals transmitting the pathogens to people. So that's a different type of intervention. And wildlife trade is an example where dynamics of proximity come into place, where you're bringing animals into contact with people through trade and through consumption. So collectively, we developed a framework that complements all this called Ecological Countermeasures, which helps us determine how we can intervene within this cascade event to stop the process from reaching epidemic to pandemic scales. So that's what's in the lower three rows here. So under scenario 1 for our ecological countermeasure goal, we have secured these dominoes in place by establishing protected areas and conservation measures that reduce stress on ecological systems, particularly wildlife. So that would be scenario 1. So another type of interventions for scenario 2 is that we manage the dynamics of proximity. We separate people from potentially infected wildlife. And then in scenario 3, we're creating barriers so that there might be some dominoes falling over in the system, but there's something that keeps them from ultimately tipping all of the other dominoes over at a certain point. So an example of an ecological countermeasure in this case would be keeping wildlife from leaving their habitats, maybe fencing as an example, keeping domestic animals and people from entering wildlife habitats instead of letting people venture through parks and protected areas. in a open access manner, maybe bringing people through on shuttles and buses, for example, to reduce risk. So just some key points to reiterate some of the things I just said. Landscape immunity is the ecological conditions that prevent higher levels of infection, setting the first two phases in the equation. And then as we relate to the later two parts, the shedding and, the spreading and spillover aspects, we want to reduce wildlife-human proximity, reducing contact and exposure rates. So we define ecological countermeasures collectively as targeted landscape-based interventions that arrest land use induced spillover. So here's an example of an infectious disease situation that you may all be familiar with, Lyme's disease. You all probably all know that there's an association between Lyme's disease and deer. That association also includes white-footed mice. And in an increasing number of environments, the association also includes an invasive shrub known as Japanese barberry. So where there have been invasions of Japanese barberry, there are increases in white-footed mouse populations. That is a host for the black-legged tick, which carries Lyme's disease and associated, the bacteria associated with Lyme's disease. And then that allows for greater transmission to deer. So in this case, we have modeled an ecological countermeasure to reduce the population of Japanese barberry, invasive species eradication. So in the middle box here, we're mitigating the risk by eradicating Japanese barberry and restoring native plant populations. And then ultimately you have a very happy scenario in the third box where you've got low risk of Lyme's disease. People are benefiting from outdoor recreation, which, as we all know, benefits human health and the economy. So managing invasive species of various kinds is an ecological countermeasure for reducing infectious disease risk in many scenarios. So quickly moving on to some of the policy implications identified as relates to the land use induced spillover model. I'm sure many of you are aware that COVID-19 has stirred action related to zoonotic diseases across a wide range of international frameworks. Some of those are directly related to human health, such as the Global Health Security Agenda. Some of them are related to ecology and biodiversity, such as the Convention on Biological Diversity. Some of them are related to sustainable development and have tendrils both in the human condition and the environmental condition, such as the Sustainable Development Goals. And then we are now within the UN Decade of Ecological Restoration, which we typically think of as a fully ecosystem-based initiative, but there is a recognition coming out of COVID-19 that the Decade of Ecosystem Restoration has explicit, human health implications and possibly prioritization in a way that has not been prioritized before. All of these frameworks are going through a sea change right now in framing their work to various degrees from a One Health perspective. That is to recognize that human health, animal health, and plant health and environmental health are all interrelated. And there is a need for a multi-sector, multi-jurisdictional, multidisciplinary approach if we are honestly going to reduce the risks. There has been discussion about bringing a number of these frameworks together to develop a new protocol on preventing pandemics. The caveat that I often make in that regard is that these frameworks, and I've just mentioned a few of them here, have for decades prior to the pandemic had priorities and international governments have come together to make decisions that are all directly relevant to pandemic prevention. Anything, for example, that the Convention on Biological Diversity has done in terms of decision-making for the protection and restoration of ecological systems has direct application to the prevention of pandemics. What we have failed to see is the actual implementation of the targets under many of these frameworks, such that the policies actually reach the ground level. And from my perspective, that's the sticking point that needs to be addressed, rather than promulgating additional frameworks. We need to look at what has stopped us from being successful in doing the 101s that were already well recognized. And then at the domestic level, the media has recognized that there is a hole in our national pandemic prevention plan, the plans that were developed in 2020 and 2021 in particular, and that is that they don't explicitly address the ecological components of the land use induced spillover equation. And if we are going to do that, we need a sea change in the cosmology of governance. And these are just a few of the examples. One is fundamentally moving from a reactive to proactive governance structure, that we're focusing on prevention rather than responding to problems after they've emerged. That we recognize environmental health as the foundation of human health. The One Health framework is helping us to do this. That we recognize that the rooting of national security is in environmental security. So in other words, biosecurity, as the term is often used, needs to have an ecological security framework, one that goes beyond just looking at biosecurity as biosafety in biological laboratories, or preventing the entry of pathogens that might be used for intentional harm. There is a development in process in terms of building interagency One Health frameworks across ministries that's coming up from the staff level. And we're increasingly seeing One Health positions in senior leadership and One Health showing up as criteria within staff position descriptions and performance. And I think those are all good signs that we're at least moving towards a more integrated conceptual framework within the agencies from the staff level on up. What we still need to see is a shift in cosmology from the higher structural levels. So just to end here with a couple key takeaway messages. Human health is dependent on environmental health, the resilience and regeneration of ecological systems across all types of ecosystems and all geographies around the world. This is an issue for the northern regions as well as the southern regions geographically. Investments in biodiversity conservation and ecological restoration are investments in human health. To prevent the next pandemic, we need to prioritize the protection and restoration of natural systems. And my favorite tagline is, we must prescribe nature. So I'll leave it at that, David, and happy to address your questions and questions from our audience.
Okay, so thank you. We had a few comments. Can you talk about, we kind of got acquainted through our writing on One Health. Can you talk about that? Like, it's not is it a government agency or government initiative, multi-government initiative?
So One Health is a conceptual framework. The idea being that human health, environmental health, plant health are all necessarily interrelated and should ideally be addressed through holistic frameworks across sectors, across disciplines, across ministries, et cetera. There are explicit One Health initiatives growing within the federal agencies. So at the institutional level, there are One Health initiatives, for example, within USAID and within CDC. Other agencies are interfacing with those initiatives as well. And there are organizations that have also picked up the term One Health, but it doesn't belong to any one entity, I guess would be a short way of saying that. It's more of a concept and an intent.
If you go to the CDC website and Google One Health, they have a lot of resources about it. So it's very interesting. For those listening, and I appreciate you attending. I know as we get summer, a lot of things competing for people's interests. Please put your questions in the Q&A box. I have two already. Human behavior is a sticky widget. How do we change human behavior worldwide to act on what we already know? That our lives, livelihoods, health, and futures rely on healthy ecosystems.
So great question. I'll paraphrase Albert Einstein with this one, and that is to say that you can't solve a problem at the level at which the problem was created. So in order to address human behavior, we actually have to look at the drivers of human behavior. And that comes down to our values, our beliefs, our sense of identity, and our sense of what we are in service of that's greater than ourselves. There has often been a disconnect in environmental education in this regard, where environmental education has focused on what to do and what not to do, rather than looking at the deeper societal constructs that drive behavior. Social marketing in the last, I guess, decade or two has really taken up this particular line of questioning and frameworks for response. So I can mention two organizations come to mind that really have done a very good job on a routine basis in bringing social marketing into environmental problem solving. One of them is RARE, a conservation organization called RARE, capital RARE. And then another one is PCI Media Impact. They have worked in the environmental field as well as many other social and governance related fields. So you could go to either of their websites to get some models in terms of how they address human behavior change through shifting of what I'll just generally refer to as cultural norms.
So we had some news yesterday. Senator Joe Manchin has decided to sign on to the Biden's climate change bill, and it's a good thing. If it ultimately passes, right now he's recovering from COVID, another senator recovering from COVID, so they can't really hold a vote yet. And there's always a question, whether the senator from Arizona, SWINY, will also join in. But were you heartened by that? That it looks like we will finally have a climate change bill passed?
I think we should all be heartened by any advances in environmental conservation as it relates to pandemic prevention, whether that's coming through explicitly legislation that is under a pandemic prevention framework, or whether that's coming in for goal sets that are more directly related to climate change, wildlife trade, or deforestation. regardless of the doorway by which we can improve our conservation measures, the ultimate outcome will be a reduction in pandemic disease risk.
So another question, and I kind of know your answer to this, but is there any effort yet at the US federal or state level to influence land use policy of public lands as guided by these findings?
Not that I'm aware of. I mean, keep in mind that the work my colleagues and I have been doing is relatively new. The land use induced spillover framework was only published in the last 18 months, or several papers we've published only in the last 18 months. But again, to reflect on the comment I just made, anything that we have been doing through time and are currently doing to protect and restore landscapes ultimately benefits our goal of reducing pandemic risks, particularly when that's done in the tropics, in areas where we have the greatest likelihood of zoonotic disease emergence. In terms of moving forward, inspired by the land use induced spillover framework specifically, no, I'm not aware of any activities yet.
So today in the news, they show that Arizona has 110 days where its temperatures are every year now, you know, that their landscape is actually changing because it's so hot there and no rain, and you have 110 days out of the year where its temperatures hit 90 to 100. And they say that the public is seemingly now starting to become aware of the importance of addressing some of these issues. I was in England. I luckily missed the 104-degree record day that was there. But when I was in Switzerland a few years ago, and actually in 2 separate summers, it was 96 degrees, and they don't really have the air conditioning we have. And when I asked about that, they say, well, it doesn't get hot very often. I said, well, every time I seem to come, it's getting pretty hot. So Europe has had a heat wave a couple of years ago in France. 300 people died. And she said, do you think there's a greater awareness among people and a greater, you know, acceptance of doing things, passing legislation?
I think it depends on what audience we're talking about and where they are in the world. You know, there's certainly I don't, to look at your question more broadly, to add a framework to it, I don't think that there's yet a broad recognition in the linkages between ecological systems and human health. So in terms of people pushing for understanding a legislative framework that explicitly links those two and moves to value ecological condition and services from a personal human health perspective, I don't think we're there yet anywhere in the world, although there certainly are efforts through the World Conservation Union and other international frameworks to bring that awareness forward. As I mentioned before, there's discussion of a protocol, multinational protocol explicitly designed to reduce pandemic risk. But as you also noted, people may not be motivated to take action until it has a personal impact. And often by the time people experience, for example, COVID for themselves, the situation has been well progressed, and we're back in a reactive governance framework rather than a proactive one. One of the challenges with proactive governance is that it can be very difficult to prove that you've prevented something from happening. So people don't have the direct experience of the event because you prevented the event. I've seen memes recently remarking that scientists ran around expressing concern about the ozone layer. And yet look, all of this time later, the ozone layer is not falling apart. We're not having all of the problems that were predicted by the scientists. The individual that obviously developed those memes and the ones that are sharing it don't recognize the fact that we put legislation and regulatory systems in place to solve the problem, so that we prevented the long-term potential repercussions. That's not immediately obvious to the general public, the act of prevention that was taken. At least at this point in time, we're not taking people's hairspray canisters away from them.
Not yet. So, I mean, I think people realize, I think with this pandemic, people thought it'd be over very quickly, in the summer of 2020. So here is summer 2022, and right now there are more people getting hospitalized, more people getting sicker. I think this is the most contagious variant, and yet the disconnect I see in your talk is that, well, not from you, but that there's very little correlation, understanding the American public that land use change has anything to do with the pandemic.
There has been, when it comes to environmental issues and wildlife, there certainly has been far more attention on wildlife trade,
right,
and wildlife consumption than on the ecological circumstances that lead to increases in wildlife trade, commerce, and consumption. That's correct.
So I have some questions from the audience I'm going to ask. What impact, if any, has human-induced climate change had on the United States?
So that's a separate topic than my presentation is this evening. But I think there's a large body of literature. There are national climate status reports that you can refer to for that information. There are teams of people working in the national government to produce reports on climate change impacts on a regular basis. So I direct you to those for specific statistics and summaries.
Another question I have is, I'm very interested in your point about scale. Do you think there's any point in individual initiatives, such as those advocated by Doug Tallamy, to create small-scale healthy environments? Or should we focus on larger-scale policy questions, or both?
Both is the answer. And for those who don't know who Doug is, Doug has written numerous books, recommend all of them, in a general way of summing up his message. You can lead your own conservation initiative through what you do in your backyard. The idea is to work with native plants, address invasive species, and essentially be your own ecological restorer. Certainly at the local level, that can make a significant difference for pollinator populations. That's one of the outcomes that Doug focuses on. For native birds, for increasing insect populations that native birds and other species rely on. On the ground is where we actually need to see the results. And as I mentioned earlier, many of these policy frameworks kind of check the box upon decisions being made, but don't actually lead to substantial changes on the ground. There are exceptions, of course. But the real focus that we need to have in terms of policy frameworks is is understanding, going back to the human behavior question, understanding what's stopping us from putting intent into practice on a large scale as soon as we possibly can. And of course, part of that is the issue of competing interests.
And so I have a clarification from the question. My question was, what impact has climate change had on land use induced spread of disease?
Oh, okay. Okay. Putting in that framework. So climate change can be seen as one of the many stressors that I mentioned at the beginning. Stress can show up in many forms. I'll give you a couple of examples. So we know that some invasive plants thrive under higher levels of CO2, vines, for example. So if you have climate change scenarios that are facilitating the establishment and expansion of invasive plants, you're functionally and structurally altering ecological systems, which will have an influence on the wildlife in those systems. So that's potentially both a direct and an indirect stressor in and of itself. And of course, if you have things like desertification happening as a result of climate change, that's another type of ecological stressor that's going to affect both terrestrial and aquatic systems. So in short, any kind of ecological alteration that's driven by climate change that causes stress to wildlife can act as an inducer for land use induced spillover.
So is the United Nations leading the initiative for One Health?
Sorry, I lost you there for a second. I lost the last part of your statement.
Is the United Nations one of the leaders in the World Health Movement and also land use change?
So the United Nations has the responsibility for numerous frameworks in sustainable development and conservation, human rights, as you're well aware of. So they certainly are providing the framework for multinational dialogue that could help move us in the right direction for the protection and restoration of ecological systems, for conservation outcomes, sustainable development outcomes, and in this case, pandemic prevention outcomes.
So several guests have said that they saw this pandemic coming, not necessarily COVID, but they said it was inevitable we'd have a pandemic. So is it inevitable we will have another pandemic?
Yes.
It is.
And another.
And another.
And another, unless we address the fundamental drivers.
So how come we haven't had a pandemic in a long time until 2020? Is that just luck?
Part of it is luck. Part of it is the fact that we've had interventions in place now, a toolbox for a number of disease-causing organisms, that are still with us, but don't reach epidemic or pandemic levels because, for example, people are vaccinated. We've improved sanitation in many parts of the world. We've improved animal husbandry. All of those things help reduce risk ultimately. But as we have improved trade, travel, and transport, we increase the risk for the scaling of events from local to global. When we have people migrating in large numbers as a result of conflict or resource shortages, we increase, the risks of people coming into stressful, crowded situations, where disease is more likely to be transmitted further and faster. And then of course we have, all of the environmental stressors that we've already discussed increasing in various ways around the world. So you bring all of the ecological and socio-political factors together, and you're magnifying, you're amplifying your risk potential in such a way that it can override the countermeasures that we've had in place.
So do you think, so I live in Manhattan, big city, we have tall buildings here, not a lot of, open land. So in a way that's, we don't have bats, coming into our cities that much, but what we do have is, more crowds. We have a subway system that where, tons of people are on. And do you think there's a real downside to living in cities? Should people be living in cities to reduce pandemics, or does it matter?
So there's a paper that a colleague, Gary Tabor, and I wrote in the journal Biophilic Cities that addresses land use induced spillover explicitly from the urban perspective. And many of the principles are the same. You can look at the ideals of urban living from multiple perspectives. One perspective is if you have people concentrated in an area, your footprint, your ecological footprint is concentrated. It's more localized in theory. If you spread all those same people out across the landscape horizontally, so to speak, you'd be directly impacting a larger land base. That said, the ecological footprint of urban areas extends far beyond the actual physical infrastructure of the urban environment. So what I mean by ecological footprint is the impact that the people have in terms of resource use and extraction that may extend across other aspects of the globe. Even every time you go to the grocery store and buy fruit that's coming from a tropical area, your ecological footprint is reaching into those tropics. The biggest issue in terms of pandemics from the urban living perspective is that dynamics of proximity issue that I mentioned, that more people in a concentrated area is going to increase the spread potential dramatically, particularly through things like public transportation, where there's high likelihood of contact rates, as well as sharing the same airspace, so to speak.
Yes, but I also have read that subways and planes are not the biggest. Although they're riskier, that it's more families and friends. Indoor gatherings.
It will depend on over time. It will vary depending on the pathogens and the way those pathogens are moved through the system. So, the spread of monkeypox in terms of controlling that transmission is different than the control of COVID-19, for example.
Let's talk about monkeypox, because a lot of people have asked me, and I'm actually looking for someone to do a show on in the next couple of weeks. And all the monkeypox researchers said we're too busy. Is monkeypox have anything to
Understandably
do with,
so.
Yeah, is monkeypox have anything to do with land use change?
Sure. Monkeypox is another emergent pathogen that arises out of natural ecosystems. It has been best known until recently as an issue in Africa, an issue often related to the bushmeat trade in terms of contact, human contact with the pathogen and spread from there. As is true with COVID-19, we know very little about the origin of these pathogens and their own biology, what other organisms host them. Several years ago, there was an incidence of monkeypox when a Gambian pouch rat was imported into the United States for the pet trade. It was co-housed with prairie dogs, which are native to the United States. And the monkeypox was transmitted from the African Gambian pouch rat to our native prairie dogs, which were also intended for the pet trade. People that were handling those animals in the distribution facility did contract monkeypox. You know, how would we have known that you put a Gambian pouch rat together, you know, with a prairie dog and you've got transmission potential? We couldn't have known that. We couldn't have predicted that. So one of the things to underscore in all of this is that the unknowns greatly surpass the knowns. Each pathogen is going to be our teacher in terms of what its capacities are. And we're unfortunately going to have to learn that through direct experience, unless we can put, you know, more resources again into the preventive part of the equation and increase our research on surveillance and the ecology of pathogens in their natural systems, so that we have the ability to enact the countermeasures before we get to levels of human exposure on a large scale.
So I have one final question. The slides are wonderful. Can I post them on our website for people who may have missed this?
Sure.
Thank you. I appreciate it. Well, I want to thank Dr. Reaser for spending time with us and explaining all about land use change and its relation to pandemics. And I knew about it because I got to meet Dr. Reaser through an article I was writing. And again, I want to thank you for your time and for your rescheduling. And I want to tell everyone to stay safe out there, and we will see you soon. So everyone enjoy the last few weeks of the summer, and hopefully everyone will stay safe. I think I have one more question. Oh, it's just a comment. Great talk. Well, I agree. Okay, everyone. Thank you so much. I appreciate it. Dr.
Thank you, David. Thank you, everybody.
Great to know you in person. Okay, take care. Bye-bye.
Bye.
Good night.